Well, welcome to the podcast, Rodrigo. I'm really excited to talk to you. How are you doing today?
I'm doing great, David. Thanks for inviting me.
So, for everyone listening, okay, Rodrigo and I spoke about a week ago trying to catch up with, and he has an amazing background working on data. But more so, what I'm excited for is that you came from academia, right? And when we were talking, you spoke about the early days of Python, and you won't believe this. I actually went and started figuring out like when was Python, and well, you talked about Python being the language in Brazil, and you were introducing it. So I went and started looking it up. Did you know that Python actually came out of Netherlands, and Ruby came
Yes,
out of
yes.
Japan? Yeah.
I met the creator of Python, Guido von Rossum. So I shake hands with him. I gave him the translation that I made for a tutorial he wrote from English into the Brazilian Portuguese language. So he thanked me. I have an email from him thanking me for the initiative. So yeah, for sure. I know that.
It's amazing because that led me a rabbit hole where I just started looking for where did these programming languages come from. So I got to know Ruby came from Japan, Lua
Yes.
came from Brazil, and then
Exactly.
yeah,
And I
wild.
know personally the creator of Lua, and I worked with Lua in Brazil as well for like 2 years or so.
That's amazing. I mean, that's why I was excited to talk to you because it feels like you've been around the tech space for a while, but then
It's
your
been
journey to tech is so interesting.
28 years, this like white beard. I've been around, but I've been working hard to keep my anonymity. That's important.
Yeah, yeah,
Being
yeah.
famous is not fun. Just among friends.
Yeah, no, I mean it's exciting. So thank you so much for coming on the podcast. And for everyone, as we just kick it off, Rod, why don't you let everyone know a little bit about who you are, what you're doing right now. You can be humble and but do a humble brag, obviously. So please go
Thank
for
you.
it. Yeah.
Yeah, so I will not be as humble right now because I just got promoted. So I'm super excited.
Wow, let's go. So what's
Beginning
your
of
new
this
role?
year,
Yeah.
yes, I got promoted to VP of engineering. And prior to that, I was senior director of data. And that's is why I will be like slightly biased towards data science, AI, because I was taking care and continue to take care of that stack within Loadsmart. And now my responsibilities expanded a little bit. But it's super exciting. Right now, I'm working for Loadsmart, so maybe introduce Loadsmart, and it is a mouthful. So I'm going to use the standard definition for what Loadsmart is, and I will read verbatim. So Loadsmart is a logistics solution provider automating freight, booking, shipping, and it's also is concerned about brokerage, freight procurement, dock scheduling, truck management, managed transportation, network optimization, and etc. So we are all over the place in terms of like logistics space, and that's why it's so exciting to be at Loadsmart because I can play. I love computer science, and I can play with computer science in all of these like interfaces with shippers, with carriers, with brokers, with dock and yard.
Right. It's amazing. When I was, after I spoke to you, I went and did a little bit research on what Loadsmart is doing. And I had no idea there was a business like this, right? Where it seems like you're right in the middle of, it's a logistics business, obviously, and you're supporting companies that drive, logistics problems, right? Or shippers, carriers, and those are your customers. And you have softwares around freights. And what was interesting for me was one of the products that you guys, and I would love to talk about it as we continue, is something where you use computer vision to figure out how these freights are moving across. And I think I understand why this is the sweet spot of AI and engineering, because these are complex problems that you're using high new level technologies to kind of tackle, right? So tell us a little bit about that.
Of course, you're talking about NavTrack. NavTrack is another startup that Loadsmart acquired last year, around September or October, if memory doesn't fail me. And right now, we're seeing a lot of other startups trying to enter on that space. So it's really, really hot right now. NavTrack is all about using computer vision to automate data extraction for all the transit that you see on the gates of facilities. And it's more sophisticated than you can imagine because when you have a truck, you have a bunch of signals that you're interested in capturing. So on the door of each truck, you are forced to have some identification. You have a state identification. They call that USDOT for on the Department of Transportation. You have the truck number. You have the license plate. And sometimes the truck, the power unit, is coupled to a trailer, and that can be a container. And in the case of container, it has its own number. And when it's a regular trailer, you can also detect seals, because at the back door, it's super important if the load was not violated. And also, you are interested in capturing damage. So all of those signals, you want to capture that. And you have like a single facility can have much more than 200 events on a single day. So it's really not humanly possible to capture all that information. And when you think about optimizing, and logistics is all about like being quick on the uptake, automation is the path. So we are concerned right now in how can we do that at the lowest cost possible. So we're trying to balance quality with low costs.
As always, I'm fascinated by people's journey, and of course you have 28 years of mammoth experience going across academia, as I was earlier alluding to. Tell me a little bit about what motivated a young Rod to get into like technology
Right,
or computers.
right.
Yeah.
So I have, I guess, the same kind of humble beginnings that many people in tech my age had as well. So if you think about the 80s, I was about like 13 years old or something like that. And the personal computer was starting to happen. So in the US, you had like lots of diversity. Back then I was living in Brazil. Even there, we had like about 4 or 5 different vendors. Some of them trying to clone Apple, which was the absolute leader at that time. And my first experience was controlling a television set, because at that time you didn't have a monitor. So you connect your computer to a television. And for me, that was mind blowing. I can control the TV. What is this? So that's what got me started. When I came to go into college, I didn't want to pursue computing because I felt it would ruin it for me, because I had such love for programming, for coding, that I was a little bit afraid. But then again, I said, hell no, let's get deeper. And it was like a great successful marriage. So I've been with computer science as a profession ever since. In a way, I was a little bit the opposite path that you see a lot happening in the US, because US was very business driven. You see people like Bill Gates or Steve Jobs that did a little bit in academia and then jumped off to markets to explore it commercially. In my case, I opted to negotiate with the industry to give me part time so I could continue my journey in academia. And that was really interesting, because I could expand my network on both sides, within academia and within the industry. And because both of them have such different speeds and approaches, they were very complementary. So I kind of strongly recommend that. It is strenuous because you invest a lot of time. It affects your personal life in a way, but it was worth it for me.
And is that when you got introduced to the programming language Python? And I know you
Oh
were
yes,
one of
that
the
story.
first people to get
Right.
Python in Brazil. Yeah.
Right. There were two different paths that converged to Python. And this is interesting. So, both in the industry and both in academia, and at the same time, both paths converge. Why? In the industry, at the time, and we're talking around 1997, Python was created around 1991. But around 1997, I was working with C mainly, and I started to explore other programming languages that would make us as developers more productive. So I started exploring scripting languages, Tickle, Perl. I was on that path. And in academia, I was doing my master thesis, and it was about computational reflection. Java was a thing, Java made reflect a term popular, and I started exploring which other languages had reflection as a feature. And from both sides, I got Python as a possible answer. And then I had a friend working for Red Hat, and he said, "Hey, we are really adopting this. It's really promising. Take a look." And I gave a talk around 2004 saying Python passion at first sight, where I told people not to fall in love for the technology. But actually, that's what happened. And I stuck with Python ever since, and it was great for my career.
The other thing I wanted to get into was, I mean, obviously you spent some time in academia, right? How was the scene in Brazil, right? Like from an academic point of view, getting into tech? Obviously, you kind of introduced how it was in the US. For you, how was information flow like? Because early 2000s, the internet was just kind of coming out, and
Interesting.
you were getting
Yeah.
introduced to it. Yeah.
Brazilian in Brazil, you have like fewer than in US top universities, but they were a part of the network very early on. So if you think 1992, which was like my first year as undergraduate, we already had access to the internet, and I was already using Mosaic as a web browser. It was not internet was not still the thing. You didn't have like search engines at the time. We had lists of FTP sites where to download stuff. So that allowed us to like really be connected, and there was lots of partnerships between Brazilian universities and foreign universities in France, in the US. So it was really kind of a nice place to be, and that remains true even today.
How did that transition from academia to tech? Obviously you were talking to tech people and you were doing your thesis and going through the motions of, and you were also educating. I believe you were in you took some time as a professor as well, right?
That's true. That's true. So what happened was the following. I did my undergraduate course in computer engineering around 1992. At that time, there was a struggle to define what a computer engineer should do. It's similar to what happened recently with a data scientist. It was like, hey, we need a new profession because we need somebody that knows business and knows statistics and know coding. That was the data science. But the computer engineer was somebody that knew computer science, but also knew the basics of the engineering discipline, physics, chemistry, math in depth. So I jumped into that bandwagon. Right after that, it came mechatronics. It was kind of around the time, but I prefer computer engineering, and it was perfect for me. So I did the undergraduate course, and I started working the last year of my undergraduate in a company that belonged to a professor. And I negotiated part time so I could continue do my master's and my PhD. And in academia, for example, in the US, MIT is really close to the industry. But the Brazilian universities follow the European model. They prefer a little bit of more isolation from the industry so they can pursue more theoretical themes and topics. So that was interesting. And I started exploring computational reflection. And then I switched to information systems, databases, and such. But at the meantime, because I was like working in the industry as well, it was really natural for me to kind of bring to cross pollinate and bring more strong computer science background to my work in the industry, and vice versa, give a little bit of more speed to what we're doing in the university because of the training in the industry. I was invited to teach in another university, and they asked me to teach introduction to programming. And I said, oh, that's interesting. And they were teaching C. I was like super familiar with C, so it was not a problem. But I also knew that C as a first language was not a good choice because you can shoot yourself in the foot really easily. With like 2 lines of code, you make one typo error, you have 30 errors. So I decided to introduce something new, which was Python. And that was way before MIT decided to use Python as a teaching language. We're talking 2004. And then in 2005, EuroPython invited me to give a speech with my experience of teaching Python to undergraduate courses. So that was like the perfect timing. And it was about then that I decided to organize a Python conference in Brazil.
That's awesome. It kind of has, I am kind of connected in this story in a way that when I went to do masters, and I did a master's focus on analytics and data science, I had to choose between R and Python. Okay. Because those were the options. And I chose Python because I felt like I had seen success of that getting applied in the industry, and how useful and helpful it was. And it's really cool to know that you have been involved in the community, building the language, giving feedback. People don't understand, especially in the open source side of things, how important it is to get every bit of feedback in improving things. And I'm glad that you're involved in that. That's brilliant. Because you brought up databases, okay, and I work for a database company and I've been in the database space for
True,
a while.
true.
Tell me a
Cockroach.
little bit about what databases you were working on, and how was that period for you?
Right. So in my PhD, I joined the group that work with databases and information systems, so search engines and the like. At the time, there were like two main topics. One of them was geographical information systems. So there was one popular system from the United States Army called GRASS, which was like really bare roots. It's mostly a bunch of scripts, really. But GRASS introduced like this new wave of modern geographical information systems. At the same time, in France, they were introducing a experimental object-oriented database called O2, which is oxygen, but it was called O2. So we play a little bit with O2. Meanwhile, in Germany, they were exploring extensions for relational databases to handle vectors, a theme that is very popular now. But at the time, the vectors were not to implement large language models, but they were concerned on the GIS space to be able to manipulate raster formats of like large imagery, because satellite imagery, it's like huge images. So it was not performance to handle those imagery in one system and then the relational data in a different system. So the Germans was exploring that in a database called Rasdeman. And I looked it up a couple of weeks ago. It still exists. But nowadays, this kind of resources, it's more pervasive in multiple databases. And my last interaction there was on the wave of NoSQL. When the wave of NoSQL started, I saw the diversity in that ecosystem that I wrote a paper called Database Descriptors, whose idea was for us to create and catalog the features of those systems so we could actually reason about which one is offering what, and we can compare and select. And I still believe this would be relevant even today, like 20 years after that. I think that project is still relevant. I haven't yet seen a meta database of database systems where we can pick and choose and understand how CockroachDB compares with like RavenDB or Rockset or Mongo or Neo4j or Virtuoso, or whatever.
Yeah, the reason why I asked you that question was because I saw that you had done something with database description and helping folks make right decisions on when NoSQL or one, and obviously I think pretty much most now we have like 1,000 database, so you need like a a really smart descriptor in the middle, kind of working as an orchestration layer to like help people choose. But now you are a VP at Loadsmart, right? Like it's a totally different role. Tell us a little bit about what your role kind of entails. We have a lot of listeners from different countries who are early in their stage, trying to follow a path in engineering and through academia maybe. Tell me about what does a VP in engineering do on a day-to-day basis?
I think there are two aspects to the question, because the first one is, should you do the transition or not from individual contributor to managerial? But your question was, once you have done it, what does a VP does, right?
Yeah,
Which is a very good question. And
let's
it
go with both.
depends.
Let's go
Go
with
ahead.
both of them. Yeah.
Okay. So let me ask first the original one. What does a VP does? And honestly, I'm still learning because I was recently promoted. But what I know is that it depends a lot on the size and the culture of the company. For example, we acquired Navtrack, and now the VP and the CTO of Navtrack are reporting to me because Navtrack had like 9 people in engineering. So they were the size of a squad in a company such as Loadsmart that our engineering was 200, now is about like 150 plus. So depending on the size of the company, it's similar to an army in the sense that you need some hierarchy to organize communication. What I've learned in that path is that as an engineer, it felt that the managerial space was always an overkill. As a manager, I learned that to make people collaborate towards a common goal, it's very, very hard. But I would say it's a little bit of a psychiatrist. It's a little bit of a switchboard telephone operator because you're like connecting communication within the company. It's a little bit about cheerleader. There are moments that you say, "Hey, let's do this." You know, it reminds me a lot of Napoleon. And Napoleon was known as the petit caporal because during the battles, he go to the cannons and helped the soldiers to actually fight, not just like being strategic. He was strategic and tactical. So this is another thing that as a VP and formerly as a director, I still could be both a little bit of strategic and tactical. And that gave me this connection with the front lines within the company and also a bridge to the top leadership. So I would say that the VP is this connective tissue between the top leadership and the actual front lines of engineering.
Very cool. So I was curious. So what are the key initiatives that your team at Loadsmart is kind of working on? Obviously, you have that NavTrack project. Maybe you can expand that a little bit and as well as talk about what else you guys are working on and how it
Sure,
all comes
sure.
together. Yeah.
Sure. So there is a lot because I'm kind of passionate about what I do. I try to go like above and beyond. So there is an inertia for me to continue to do what I was doing as a director. So as a director, I was in charge of the data stack, and that represented the basis, data engineering, and then we had the middle, which was data enablement, which kind of organizes the schemas, organizes the lake house, understands the concepts within the company and how the data flows and publish dashboards and reports and etc. All the way to the top with the machine learning squads that try to create products on top of that data. So that is the inertia that I keep doing, but it's expanded because now I have also 2 product lines. One of them is NavTrack that we already talked about, and the other one is called OpenDoc, which is appointment scheduling system, which was another company that was acquired by Loadsmart and now incorporated into our product lines. And for these, it's more like regular managerial work for a software product. So understand quality, check if we have observability, understand our agile processes, innovate, test coverage, the works, the traditional. But the data stack has its specific nuances. So depending on if you are going to be a VP of engineering, depending on your focus, you may dedicate more time to one activity or the other. Right now, I'm super excited about one project that I am launching, which is to map our architecture as a database. So the initiative that we had in the past was to map the architecture, but for visualization purposes, for human comprehension. What I want to do now is capture the architecture of our systems, but in a representation that we can incorporate as a database that a software can reason about our architecture. Because we're getting to a point that complexity is becoming so high that I don't trust anymore just the human reasoning on top of drawings. I want to have like machines helping us to reason about what's flowing there. And then I can query the status of my architecture a little bit.
Right. Well, that's interesting. So it's a fascinating idea, and I feel like you're using some sort of a large language model approach along with it. If I'm
Oh
not
yeah,
wrong, you don't
interesting.
have to give me the secret sauce, but
For
yeah, I kind
that,
of get
for
it.
that one, not yet. We
Yeah.
do have two projects using large language models today. One of them, it's embedded on one of our product lines called Shipper Guide. And basically, we're using it to translate some interaction, conversational interaction from a user into a SQL query over the analytical space and then translating that as a dynamic report. Traditionally, software was designed with a priori decisions about analytics. So the designer said the customer is interested in seeing the information with this aggregation. Maybe they give some controls in terms of time span, but the metrics and the aggregations were pre-compiled in the software, hard-coded in the software, if you will. And what conversational interfaces are opening up is that we cannot design these heavily upfront. We can bring the customer as a co-designer and let's then express what they are interested in. And then the LLM helps us in the flexibility of the execution. It was key for us not to incorporate our database into the LLM simply because a big problem, and maybe I'm anticipating a question here, but a big problem of LLMs today, in my mind, is compartmentalization. That term I borrowed from, have you seen recently Oppenheimer?
Oppenheimer, yes, I did watch the movie.
Oh,
Yeah.
so in Oppenheimer, during the Manhattan Project, it was co-managed by the general Leslie Groves, and the general was super concerned about what each squad within the project knows, because they don't want to leak information to the enemy, which eventually leaked to Russia. Different story. But the thing is, we want to do the same. I want some clients to be in a sandbox. And sometimes for the same client, if they have branches, they ask us, hey, a manager of a branch should be isolated in the data of the branch. I don't want them peeking on the other branch because of competition or whatever. So you need to be able to define those walls, those barriers. And that is super hard. And I don't think we still have a complete answer when we bring LLMs and the probabilities and the flexibility into the picture.
True.
How can we enforce that control?
Yeah. No, I mean, I've thought about this question, this whole issue about, like, I have consistently been, I see there are three problems. I mean, now that we're on the topic with the large language models, is the hallucination problem, the consistency problem, and the third one is the compartmentalization problem. And when it comes to enterprise, I feel like these three are very concerning, right? Especially the idea of compartmentalization that you brought up. And the solution is to have, instead of having, I don't know what the actual solution is, but I've thought about is having multiple small large language models working within their ecosystem as a crew, with their own RAG databases, so they can separate and add that isolation, and then you have an orchestration on top of that that chooses where to send which request to. So so yeah, that was something that
That is
I've
for
been
sure a
thinking about. Yeah.
possibility.
Yeah.
We've been exploring multiple paths. We still don't know the answer. One strategy was to, when it's possible, and you can filter the data a priori, it's the safest way, right? So you give like a subset of the data that is always safe for the LLM in the given context to explore. However, when you get more ambitious, that is not an answer anymore, because you want to give the LLM all of the data that you have available. And in that sense, we explore like two approaches, which is one of them prompt engineering, to try to teach the agent where to look and where not to look. That's one possibility. The other possibility is let the agent do its thing, but before you expose the rest of the data, then you try to filter out there. It's
Right.
another
That's a
possibility.
fair point. Yeah.
Yeah, and because we're doing LLMs with SQL translation, we're also exploring treating the SQL query produced as data from the agent and then manipulate its abstract syntax tree to try to identify whatnot and do like SQL injection there,
Yeah, yeah, yeah.
but a good one to like adapt the query to adhere to your security policies.
Right, right. Yeah, no, that makes sense. And so, I mean, I've been exploring LangChain and been using the SQL toolkit that's available. And one of the things I don't like about the SQL toolkit is that it does 4 steps, right? From schema reading to doing all of those things. And I was like, what if I just can inject the exact place it needs to go look for and not to think about it, you know? So those are some of the problems that I have kind of in my side stuff I kind of explore. So
That's like a super hot topic nowadays.
tell me a little bit about the tech stack that you guys are using to kind of enable this experience to your customers. And
So when I joined Loadsmart, I joined 2 years ago, and by that time, Loadsmart was already, I guess, 6 or 8 years old already. So the tech stack was kind of already in place. It was mostly a Python shop. So the majority of our systems, at least on the backend side, are implemented in Python, which I believe for a startup makes a lot of sense. Because today, a lot of people complain Python about Python being slow, but actually, Python is fast and maybe one of the fastest when you think about the developer performance, which is what's really critical for a startup. And in terms of execution time, it only comes later. So the choice of Python was a good one because it gave flexibility and because Python was a language that grew on interoperability, on having a rich ecosystem, of being multimodal, of being on every niche. It was a no-brainer choice. So that's why we have it today. We do have a couple of systems here and there with Golang. For the front end, we have a bunch of JavaScript and TypeScript is an improvement for sure. We have very few systems with JavaScript at the backend, with Node as the backend. But in terms of programming languages, this is the majority of our stack. We are mostly on AWS, and then a multitude of services in there. We have our Office system on GCP, which is a no-brainer as well. And we're doing AI with Azure today. So we are truly multi-cloud.
multi-cloud actually, that's really cool. And that's the fascinating thing, right? Like, I mean, you've been in the space for 28 years, and especially this is a golden age for people who are getting into tech. The amount of databases we have access to, the programming language, architectural design patterns is fascinating. I was curious to understand from your perspective, what are your opinions on the kind of scale at which you have to build these systems? Like, what's your architectural design process?
We do have a bunch of mechanisms within the company to try to guarantee quality. So we have RFCs. So whenever an engineer is going to propose something, we have one Slack channel where we keep publishing RFCs for people kind of to join comments. We borrowed the brain trust mechanism created by Pixar. I don't know if you're familiar with the brain trust from Pixar. There's a great book by Ed Catmull, pioneer in computer vision and computational geometry. The guy who created the first hand in 3D, and one of the founders of Pixar. So in his book, Creativity Inc., he mentions the brain trust mechanism created by him, John Lasseter, and Steve Jobs, where you brought a bunch of directors to judge a particular movie storyline. And we do exactly that with like the same shape inside Loadsmart. So whenever there's like a big project which influences cross squads, they can summon the brain trust. And that means staff engineers or senior engineers can join to a session where in 15 minutes, the proponent presents, and then it's subject to a round of questions and what ifs and pay attention to this and suggestions. So that works really well. In addition to that, we had the architecture board of review. That was another thing that kind of keep a look on everything that was going to production and double checking if there's like yellow flags of sorts. So these are like the mechanisms. But honestly, it's all about communication. It's all about exposing what you want to do and interacting with people in the company. Linus Torvalds had a great phrase: given enough eyeballs, all bugs are shallow. And I truly believe in that.
You worked on a project related to Gatorade, which very fascinating project where you are able to do sweat analysis to kind of figure out, how, or based on, what the work is, what their, overall health metrics and things like that. What was that project all about? Because it's really cool to know someone is looking at data at that level.
That project was super exciting. It was one of the most challenging projects I have ever worked on. And it was one project that I kind of used all my computer science background. So, what was the project about? Gatorade was launching a device which is called the Sweat Patch. So, it's like a patch that you can glue into your forearm, and then it has two dots to capture your sweat. One of them will fill up with your sweat. The other one will fill up a band strip that will react with the sodium in your sweat. So one is capturing the volume of sweat. The second one, how much sodium do you have in there? And why is that relevant? Because for a high performance athlete, think somebody running a marathon or like in a long-term cycling competition, it's really important for them to understand how they need to hydrate, either before or during or after the competition or the sports event. So for that, we went to the Gatorade Sports Science Institute and we collaborated with the sports scientists to create formulas that not only would make sense from the scientific aspect, but would also enable the needs of application that you can download in your phone, scan the patch, and then have recommendations about what happened there. So how much you need to hydrate, nutrition, how it influences your sleep, active recovery, best practices. So it was like super cool.
Yeah, that's brilliant because I know now there are a lot of companies who are trying to solve that problem. Like there is a company who has a mattress, and that mattress measures how I sleep. And I don't have that mattress; it's super expensive. But regardless, I mean, it has all of this data, and data has allowed everyone to kind of optimize on this experience, right? You at Loadsmart are optimizing the freight experience, right, and the logistics side of those things. I know you worked at another company at Work and Co, where you worked on Philz Coffee, I believe, and that was a fascinating project too, because the problem you were trying to solve was a long wait times at a coffee shop, and you worked on an app that allowed it to like shrink up. Tell us a little bit about that one.
Sure. This is an interesting one because I was just coming from a data science background, and that was, if not the first, my second project at Work and Co. And Phil's came to us with a business problem. It was not about technology. It was simply, hey, we have all of these stores in LA or in San Francisco, and we are so popular that we're getting very long lines. And we start to losing customers because they just want to have a coffee. And then they realize it's a 2-hour line. So forget about the coffee. So how can we solve for that? And discussing with them and pairing like with business experts and technologists, I came with the idea, which is the same thing that you do with your like physician. So you schedule an appointment, right? If everybody went to the doctor and waited to be like seen by the doctor, we have huge lines. And in fact, in Brazil, we do have sometimes. But there, the idea was, let's schedule for you to have your coffee. You are in your office. You wanted to go down and have a coffee with friends. You could schedule. And then when you get there, it takes like about 5 minutes. You get it hot already on the counter waiting for you. So that was the proposal. And then we used data to analyze behavior. So I created an index I call the Explorer Index that measure if you were faithful to always the same product, or if you were an explorer every time trying a different product. And depending on that, when you open up the app, we would show to you either the usual or something that challenges you. So all of that detail came from data science to enabling the designers to make the right choices for the app.
Right, that's amazing. I mean, both these projects and the Loadsmart project that you've described is so fascinating because data has become so integral to whatever we are experiencing in today's day and age, right? And of course, we're talking about LLMs a lot, but there is a lot of other machine learning data related activities. The scale at which data needs to be stored and analyzed and trained has changed a lot, right? And what do you think has been the biggest driver for this change, really? Do you think that it's just that we are building systems that are able to capture this data at scale, or you just feel like we have reached a natural zenith where we are like, okay, we have solved all these problems and data is the problem that we need to like maximize and optimize on?
That is a very deep
It's a
question.
loaded question, I know, but
Yes,
yeah.
and I love it. I love it.
Yeah.
I once heard from, I think it was Leslie Lamport. Leslie Lamport, the guy who created LaTeX, which is like a documenting system. Also, he was the guy who created the algorithm that Google uses for like avoiding conflicts in concurrent access. So Leslie Lamport, big computer scientist, was giving a speech for us, and we asked to him what was like the big change that the internet introduced. And Lamport said it broke the monopoly on publishing. So in the past, to publish anything, it was a struggle. But the internet made anybody a publisher. So that thing, I think, was the first step towards the deluge of big data that we had, right? So we started producing a lot of data. Of course, like the mobile devices, IoT, it adds up, right? But that means it's data everywhere. And together with that, open source also contributed to break the monopoly of digesting data. So right now, not only data is plenty and accessible, you can also analyze it, even not being a statistician. So you have like mechanisms that make it accessible for you. So I believe that is what it compounds the how the world changed, and now data is like air that everybody needs to breathe in and out.
I mean, you are consuming it either even without realizing it, right? Like, I mean, and there are parallels that I see. Like there's parallels in which we had infrastructures, and then from infrastructure we went to VMs, and then we went to Kubernetes containers. That's a path. You had databases who were, and that no traditional databases, SQL databases. Now we have distributed SQL databases like CockroachDB and some others. There is another path on a hardware level where we got introduced to personal computing. You were talking about how initially early on you had to connect to a TV and start using that. Then we went in 2008 to a mobile computing, and now we are moving into a spatial computing era with Apple Vision Pro coming out, and there's so much. But the interaction is all through data, right? All of these systems are producing data, and we are making more intelligent. So where do you think are we going in the future? Now I know
Right.
you've been in the space for a
Crystal
while.
ball time.
Yeah, crystal ball time. So tell
Right.
me, what are you fascinated about? Where this is going? Where do you think Loadsmart can take advantage?
Right. So let's talk a little bit about AI, because AI has everything to do with the future, right? I remember when I started studying AI, one of my professors said, whenever we don't know what it is, we call it AI. When we really know what it is, we give it another name, and it's not AI anymore. So it's a little bit of that. For example, machine learning, it was not called AI, but it was like a spawn from the AI bandwagon. Right now we have like LLMs and AI, the moniker came back. What do I think is going to change? I think what's going to change, if we just think about LLMs, and you mentioned Apple mixed reality, and mixed reality is like another broader topic. I just read an article where they were saying, should we use virtual reality, augmented reality? Why mixed reality is really the best term to describe what we're going to face. So let's pick just these two, LLMs and mixed reality. What I believe we are about to experience is the seamless interaction with the digital world. So in the beginning, when we have like the microcomputer revolution, we had the mouse and the keyboard as the main revolutionary widgets because they transform the experience of interacting with the computer. Because before that, we were using the same experience you had with looms, the Jacquard loom, where you have punch cards to define the patterns, to program and control the thing. So the keyboards and the mouse became that thing. And now we're seeing the new wave where we're losing the mouse and the keyboard and we're transitioning to voice, to English, and to overlapped vision as the seamless interaction with the digital world. So that's what I forecast in terms of what is the big change. I think the biggest impact will be on the design because the way we build applications today, it's completely towards the affordances of a computer screen and the keyboard and the mouse. And we will need to completely change the way we design those applications because these new affordances demand a new process, a new mindset, a new philosophy.
What is your advice to people who are trying to transition and modernize their application? I mean, because a lot of us will have to modernize their application to these new paradigms. Where do they start? What should be the things that they should be looking at in their existing systems?
It depends on context, right? For example, there's one answer if you have like ample time, like you are a student and you're about to do a PhD. Another one is if you are a startup company. Another one if you are a big company. So my first answer, generic one, is be mindful of your context. Don't blindly jump into any advice from anybody that does not adhere to your immediate needs. So my advice is try to find convergence on what you're interested and what you can have like short-term, mid-term, long-term benefits. So for example, for a company such as Loadsmart, right now my struggle is to educate the non-technical leadership in ways that AI can amplify our product lines, bring value, bring show the ROI, and that's a very hard question to answer. But that is my struggle right now because as long as I can convince them, I can switch from short-term results to mid to long-term results because they are invested, they become sponsors of it. So, if it's just about learning, my suggestion is like do a deep dive. My personal strategy is try to get hands on because it's the only way that you really understand what's happening in there. Sometimes we try to get a superficial understanding through metaphors and such, and that leads us to the wrong conclusions. So you really need to have a concrete grasp of what is this all about, that then you can make decisions on top of it. I don't know, David, if I answer your question.
This is a great answer because you're taking it a little bit more behind on talking it from where you are kind of perspective. There's no one answer to this, obviously, because everybody's situation and what they're working on is different. But thank you for that. I am curious because what we have noticed, I'm noticing a lot, at least in the space, is that there is so much new technology coming up that sometimes it's difficult to keep up,
Oh,
right?
it's
Yeah,
overwhelming for
yeah.
sure, and that's important. Just a tiny little augmentation on my previous answer, which is be aware of the hype. The Gartner have this famous like the hype curve, and depending on which stage we are on the new technology. So be aware of that because there are many times that depending on your problem, there is already an answer for
Right.
that.
And the reason why I was going in that direction with that question was that you have to obviously deliver product for your company that serves your audience, your customers, your stakeholders, but at the same time you have to continue to innovate. How do you continue to encourage your engineers to continue to deliver while at the same time be innovative, do your R&D, come up with ideas and ideation process and things like that? How do you go about that?
Right. So, first of all, you need to have a leadership that is brave enough to try for new things and at the same time wise enough to not do that in a crazy way. So you need to have that balance. So that's the one thing. If you go to either extreme, I think it's the path to failure. The path to success is really a balanced path. You need to create those mechanisms for innovation. So as a manager, you need to create a space for your teams to innovate, do hackathons, do coding dojos. We had a computer science club, simply a time to discuss computer science topics. Most importantly, hear what people have to say. So sometimes leadership just wants to come up with the answers. On the contrary, I believe we need to hear, because they are in contact. They can bring good ideas no matter what level. Could be an intern, can be a junior. So listen to them. Don't humility of in a way. And the other thing, I would say, don't be afraid to experiment.
Yeah. And, I've been listening to you for 50 minutes. Obviously, we've been talking, and I can see your passion in everything that you have done since the very beginning. So I'm going to ask you this question. If you were not an academia computer engineer, what would you be doing instead? Have you ever thought about
Interesting.
that?
Oh, that's a great question. So when I was a kid, there was a phase that I want to be Sherlock Holmes for a long time. I want to be Sherlock Holmes. And I grew a little bit better. I grew a little bit older, and I decided I want to be away from crime. So, and then I decided to be an aeronautics engineer. I wanted to work with satellites. Funny enough, when I was on the verge of getting the best school in Brazil for that, I learned from one graduate that the majority of them was going into informatics, into computing. And that's why I said, okay, so it's better to go into computing anyway. And my first work as a computer engineer was to calibrate links to satellites.
Nice.
So
Wow.
in the end, it all works out.
It's all worked
It
out.
was
Yeah.
meant to be.
No,
And
it's
being a
amazing.
data scientist, it's a little bit of being Sherlock Holmes with
Right.
data. So that's why I'm super happy.
Well, Rodrigo, I have to say, it's been such an absolute pleasure. I just feel like there is so much we can talk about. Like, we can keep going on, but we need to respect the boundaries of your time as well as our listeners. I believe, this is my feeling, that this is just one of our first conversations. We should be doing more. Yeah. With that said, where can people find you? Like, if they want to connect with you or follow what you have done, tell us a little bit about where people, listeners, can kind of follow you.
Sure. I joined all the social networks very early on, which allowed me to get the moniker Rod Senra. So RODSENRA. So it's my personal email, it's my Twitter, it's my LinkedIn account, it's my Instagram account, it's my Facebook. So if you type Rod space Senra at Google, very likely I'll be one of the top hits there. And you can find me in the network. I'm in the
That's
metaverse.
that's awesome. Yeah, you'll be in the metaverse soon too. Yeah. Brilliant. Awesome. Well, so everyone listening, thank you so much for listening into this episode. It's been an absolute pleasure to have you listen in on this, and Rod as a guest for coming on. I'm really excited to see what you're going to do more, amazing projects, and let's stay connected. And with that, thank you so much once again.
Absolutely. Thanks for having me, David. It was a joy.